Yeah, so lately we've been looking into a lot of different boat building materials. So today I want to show you guys some of the different properties of different boat building materials and a little bit about the reasoning why we decided to build our future boat from timber with glass fiber and epoxy in a strip plank construction. So I have some different samples here that will test really the weight to strength ratio, because all of the samples you see on the table have the same weight, 390 grams each. But you can see that the density is quite different on the different materials. So what I will do is that I will test the materials here. I will put the buckets on the sample and put these bricks and stones in there and see how much the sample will deflect and how much it will take to actually break the sample, if we can do that with this amount of bricks. This is around 100 kilos, so we'll see how much the samples can take. I know that some of the sample will probably not break by this amount. It will probably take a lot more.
To prepare for the test, Johan laminated a couple of samples with epoxy and fiberglass. Then he cut all of the samples into the right size, so that they would all have the same weight.
So a short introduction of the different materials. First we have steel. It's a very common boat building material, and I can understand why. It's really cheap. This piece costs $1. Big ships are built from steel. I would say that building a small boat from steel is probably not very good. You need to get up to around 45, 50 feet, I would say, before it's really good. Otherwise the boat will be pretty heavy, because it's not very strong compared to its weight. You can see it's fairly easy to bend it like this. And remember, this piece has the same weight as all of the other samples you see on the table here. One of the main benefits of steel is the abrasion resistance. It's really hard to scratch steel. So if you're hitting ice or rocks, steel can take a lot before you scratch through the material. The downsides are, of course, it will rust, so you need to protect it with the paint system. You also need to design the boat so you won't have condensation water or anything like that standing against the hull on the inside. A lot of sailboats built from steel, they actually rust from the inside out, so you need to take care of that. But you can build a really sturdy and tough boat from steel for less money compared to some of the other materials you will see here. So I understand why ships are built from this. Next up we have aluminium, and this is a cool material in my book. It's, this is 6 millimeter. The steel sample was 2, but it's same weight, but you can already see that the force that I need to put on this to bend it is a lot more than I need to do with the steel. They say that aluminium is roughly 3 times as strong as steel by weight. So, and you can really tell that when you're just doing like this. Aluminium doesn't have the high abrasion resistance as steel has, but compared to other materials like fiberglass or wood, it's still pretty high. It resists corrosion pretty good because it will get an oxide layer on top that will protect the metal, so you don't need to paint it. That's really cool. On the downside, it's pretty hard to get paint to stick to aluminium. So if we would have built a boat from aluminium, we would have left it bare. You need to take care that your electrical system on the boat is in good working order, because otherwise you can get corrosion problems with aluminium. And also you should never mix aluminium with other metals that are more noble. So you need to have a really good and working sacrificial anode system on the boat to prevent corrosion on this. Another con is that it's fairly expensive. It's, this piece is $4.10, so pretty pricey nowadays. But I can really understand why you build like expedition boats and stuff like that from this, because it's nice material. Next up, we have some normal Swedish spruce that it's most often used in normal house building. So this piece is just from the local lumber yard, but I have put some glass fiber and epoxy in 2 layers on each side, 300 gram times 2 on each side. I would say the main benefit of Swedish spruce is that it's very light. It's around 400 kilos per cubic meters. And it's also very cheap. You pay this piece together with the glass fiber and the epoxy is $1.47. If you buy 1 cubic meter of Swedish spruce, it's around $650 at the moment. So very cheap. And it can take a lot of force. It's very strong compared to its weight. The downside, or some of the cons, is that it has a lot of nuts in the wood. So you will have some waste because you need to cut those out when you're building a boat from it, because you don't want to have those weak spots in a boat hull. But I have left them in now, so we'll see how this piece will behave when we're testing it later. Yeah, next up is just a normal piece of Swedish spruce without the glass fiber and epoxy. So you can see it's a bit thicker to get the weight the same as the other samples here. Very cheap. This piece is only 64 cents. Next up we have Douglas fir, which in Europe for some reason is always called Oregon pine. I don't know why, but if you buy it here in Sweden, it's called Oregon pine, but in reality it's Douglas fir. I don't know if there is a wood called Oregon pine in Oregon. Maybe some of you guys can tell me about that. But anyway, this is Douglas fir with 2 layers of glass fiber, same as on the Swedish spruce, with epoxy. Bit thinner since Douglas fir is a bit more heavy than Swedish spruce. But I don't know a lot about this wood, but you can see it has some really nice straight grains and no knots. So it looks to be quite good boat building material. Next up, we have another sample of Douglas fir, but without the glass fiber and the epoxy. A bit thicker to get the weight correct. And then we have the traditionally go-to material when you're building a strip planked hull, Western red cedar. And this is a really nice type of wood. It's so light, it's like 370 kilos per cubic meter, so a bit less than the Swedish spruce. And you can see it has some really straight grains, no knots, and it's fairly rot resistant, so really nice boat building wood. The downside is that it's really expensive at the moment. This piece here is $6.10, and if you buy 1 cubic meter of this, it's $6,000. And like I said, the Swedish spruce over there is $650. So this wood is almost 10 times as expensive if you compare it to the Swedish spruce. But anyway, it's really nice material. You can see the thickness here, 40 millimeters to get the weight up to 390 grams. So really interesting to see how this will cope in the test. Yeah, and last we have the Divinycell with glass fiber and epoxy. And on the inside here we have 11 layers of 300 gram glass fiber with epoxy and 15 layers on the outside here. This Divinycell is called H60, which means that 1 cubic meter of this weighs 60 kilos. I would say the main benefit of Divinycell with glass fiber and epoxy like this is that you can build a really light construction with this. Also the core material is rot resistant, but you shouldn't get water in there because you can get other problems like delamination, especially up here in Sweden if it freezes when it has water in it. One of the downsides of this, I would say, is the price. This piece is $6.29, So pretty pricey, but it will be really interesting to see how much weight it can take in the test here. Yeah, and one note on the prices I've been talking about here. You have to take those with a big grain of salt, because these are the prices that I will get here in Sweden, and of course that will differ a lot depending on what region you're in the world. I would guess, for instance, that Western red cedar won't cost $6,000 per cubic meter in Canada like it costs here. Also, a short word on the actual testing that I will be doing here. This is not the scientific test, it's just me in my barn showing you guys some differences between these samples I have on the table. Really the strength to weight ratio and how the different materials compare to each other. So yeah, let the testing begin. So I think we will start the testing with the Divinycell to see how much that can take. We put the outside skin on top, I think. Something like that. About in the middle. And then we'll start to load this up with some bricks. One brick is about 4 kilos, or what's that, 8 pounds. That was the first sign of that it couldn't cope. We have some delamination here. And we have 24 kilos in here. I bet that this delamination here is because this is hand laminated by me, and you would get a lot better result if you would do this with vacuum bagging and stuff like that. But we don't have that. We can't build it like that, so this would be the way that we would build it. 44 kilos, and you can hear it cracking. Oh, yeah. It failed. It failed on one of the sides here. So it yeah. But still pretty impressive. 40 kilos on a 25 millimeter wide piece like this, 390 gram piece. I will give this, I mean, it failed at 44, but it started to delaminate already before that, so I would put 40 kilos. And next up will be the Douglas fir with glass fiber on both sides with epoxy. See how much that will take. 24 kilos. I would say it's deflecting roughly the same as the Divinycell did at this weight, around 8 to 10 millimeters, something like that, I would say. So that's 40 kilos. This is where the Divinycell failed, but the Douglas fir with the glass fiber and epoxy is still going strong. So we're at 72 kilos. These are 5 kilos each. 86. That's 90 kilos. That's pretty amazing. That's my weight. I weigh 90 kilos. So if I would stand on this small piece of wood, it will still cope with my weight. Pretty cool. I don't know if I don't have a lot more stones. Here's another 5 kilos. So 95. And the rest of this I know is 5 kilos. This is a bit lighter, but lighter material. We'll see. So when this is on, it's 100 kilos. You can hear a little bit of cracking in the wood. You can easily take 100 kilos, twice if you compare to the Divinicel piece over there. This piece of concrete is about 15 kilos. So try to put that on here somewhere. It's deflecting so much, so when I put this on, it reaches the floor. I think we cut this test short here because I can't put much more weight on it, but really cool that it can cope with over 100 kilos of weight, this small piece of wood. So now we'll take the weight off and we'll see if the wood will spring back to its original shape. As you can see, it's almost back into shape. There's some delamination, or I think it's the glass fiber that it hasn't come loose from the wood, but something has happened with the glass fiber here on top. So I'll put 100 kilo plus on this sample. I guess a lot of these samples will be that. Next up is the natural Douglas fir, a bit thicker but without the glass fiber and epoxy. We'll see how that will cope. This wood, by the way, costs around $2,800 per cubic meter. So a bit less than half compared to Western red cedar. So all of the samples I have on the table there, they're 25 millimeter wide, so around 1 inch. It's only the thickness that differs. One layer, 12 kilos, 44, 64 kilos, 100 kilos, and that's just wood. 130 kilos. Pretty impressive. It took 130 kilos to break it. I will write broke at 130 kilos. Now we're testing the natural Western red cedar. I'm betting that this piece will be really tough to break. It has such an even, straight grain, not a lot of irregularities in the surface there, so 48. With 130 kilos, the deflection here in the middle is only a bit over 10 millimeter, maybe a bit more, 15. I bet this piece of wood could take at least another 70 kilos or so. That's pretty amazing. That's 190 kilos. And it has no... I actually had to jump up and down to get it to break, but it had no problem with 190 kilos. I will put 200 kilos on this. Again, not a scientific test, but quite interesting. And remember, all of these pieces are the same weight. Now we have the Swedish spruce, gran, the natural one without glass fiber on it. This is really interesting because this wood is really cheap compared to the Western red cedar. So it'll be interesting to see how the performance versus price turns out. $72. There we have 100 kilos. I would say it's deflecting a bit more than the cedar, but not a lot. Let's put on the extra weights on top. 30 more kilos. So that's 115, 130. And there it is, 130 kilos. But I have to say, really good performance to price ratio. This piece here is 64 cents. And the Western red cedar piece, that's over $6. So the last wood test. And this is Swedish spruce, but with the glass fiber on both sides. 82. No cracking sounds yet. Seems to be coping fine. That's 100 kilos. Let's add the extra 30. 130. Yeah, pretty big deflection there. But that's the thing with the glass. That it really adds strength by keeping the wood together. And I can add to that too, that the hull that we will build will have more glass fiber than this. Mainly because you want to have some protection if you touch something. If you go against a dock or anything like that, you want to have more protection than this to prevent water from getting into the wood. So that will be even stronger. Also 130 kilos. But, you know, you can't compare one piece of wood directly to another one because there are so many variables in wood. The other piece was thicker, failed at 130 kilos. This piece is thinner but has the glass fiber on and also failed at 130 kilos. So the take from that is that the glass fiber helps because this piece was thinner but could still cope with 130 kilos. But there's definitely a lot of irregularities in wood that you can't really calculate. Last but not least, we have the two metals that we're going to test, aluminium and the steel sample. And I think we start with the aluminium piece. As you can see, there's already now some deflection only with the weight of the buckets here. And of course, metal behaves a bit differently than wood. Since it's a lot thinner, it will behave like this. So what I will try to do here is just put some weight on and then take it out and see if the aluminium will come back to its original shape. And then we'll see how much weight it will take before it deforms. Because this piece won't break, it will just bend. So I think that will be a more telling test to do on the metals we have here. Let's start by putting in 4 kilos. Seems to be okay. 12. And then we'll see if it will come back from that weight. Yeah, no problem. Well, it's still a straight piece of aluminum there. We'll add some more weight. 20, something happened. There it deflected. Now it's bent. Somewhere between 16 and 20 kilos to deform 6 millimeter aluminum. The nice thing with aluminum is that, you know, it won't break. You can just, it will just bend like this. So if you hit something in the water, it's probably very likely that you will just have a dent in the hull. But still, this is kind of telling. So I will put 20 kilos on this one. And then we have the last sample, steel. You can see already now that it's deflected already now by its own weight. And if I have calculated this correctly, this will start to deform somewhere around 5 kilos, around a third, between 5 or 6 kilos, a third of what the aluminum could take. But we'll see. It can't even take the bucket. I will just put some weight in there. You can see that these buckets are already on the floor, and we have already now quite some deflection in this piece of steel. Or let's see if it will come back to its original shape if I remove this. No, it's already deformed, just with the bucket. Pretty telling why aluminum is superior in strength compared to steel if you compare weight to weight. I will put 2 kilos.
This is what the samples look like now. Did you get surprised by any of them?
That concludes my test, and pretty nerdy video, I know that, not a video for everyone, but I hope that some of you found it interesting, and I know that this test didn't show all the properties of these different materials. It only show strength to weight ratio, and I know that steel and aluminum has other properties that are also important, like abrasion resistance and all of that. But it was pretty cool to see how strong wood is compared to weight. And I mean, cedar, really impressive. 200 kilos before it broke, but it's pretty expensive at $6,000 per cubic meter. I have to say that the winner price performance to strength must be the Swedish Spruce. I mean, 130 kilos, and this piece is 60 cents. 1 cubic meter is $650. The Douglas fir, I mean, I didn't test the one that have the glass fiber and epoxy until failure, but my guess is that the number would have been pretty similar to the Swedish Spruce, 130 kilos on both, because that's the number I got from the natural Douglas fir. I would say that the loser in this is, at least price performance wise, is the Divinycell. This was really disappointing at only 40 kilos. Of course, this would have been much stronger if I would have used vacuum bagging to do this laminate. But then again, we won't build a boat with vacuum in this barn, so it would have been handmade, and then I think this number is quite correct. So, and this piece is the most expensive sample of all of them at $6.29, and it only took 40 kilos to break it. Of course, steel only took, I don't know, 2 kilos or maybe 5. It was hard to tell. But then again, this will have a lot of support, of course, on the inside of a hull. You build a steel metal boat, aluminum or steel a bit differently than you would do with other materials here, but still, this weight to strength ratio is the same. But steel is a lot cheaper, $1. So I learned a lot from this test, and sometimes it's nice to just test something by yourself, to see it with your own eyes. And this test helped me to convince myself even more that wood core strip plank boat with glass fiber and epoxy is the right way for us to go. And you might wonder which wood we will choose, and we haven't really decided on that yet. I mean, the Swedish spruce is a really strong contender, and I think we will actually pick Swedish spruce, but we need to find a good, a higher grade than this one at a lower moisture level and also with less defects in it. And if we can do that, it will probably be Swedish spruce. If not, we might go with the Swedish fir, which is pretty similar, I would say, to the Douglas fir. At least the weight is about the same, and I think the strength is also probably around the same as this. But at a lower price level, it's around $1,200 per cubic meter, and the Douglas fir is almost $2,800 per cubic meter here in Sweden. You might wonder how we will cope with this less abrasion resistant that you will get from aluminium and steel. We will put in watertight bulkheads in the front and in the stern of the boat, so if you hit something and you get a hole in the boat, which is very unlikely, but if you do, you could still continue to sail. And I can add to that the main benefit in my book with aluminium or steel is not that you can really, hit an iceberg with it. I mean, if you sail in Antarctica and there's a big roller, a big chunk of ice floating just beneath the surface, and you sail in that with in heavy seas, and you land a boat on top of a growler, it doesn't matter what material your boat is built out of. You will just split the hull open and you will go down. But let's say if you're in an anchorage and the wind turns and push a lot of ice into that anchorage and you need to push your way out, then of course aluminum and steel is superior because it has a higher abrasion resistance, which the other materials don't have. So that's it for today, and I know this is a very opinionated topic, almost like which anchor is the best or catamaran versus monohull. So yeah, go easy on me in the comment section. See you next week.